Okay. So I guess we can get started with the prayer. I can go ahead and say it since I haven't said it in a while.
Okay.
Our dear Heavenly Father, we're grateful for this day that we have to come together here to study more about this math class and to do our group quiz together. Father, we're grateful for the knowledge and enlightenment that Thou gives us in our lives to allow us to progress in college and in our own personal lives. Please bless each one of us that we may be able to continue to do well in our studies, that we may learn the things we need so that we can continue to advance properly through this course. And we say this in the name of thy Son, Jesus Christ. Amen.
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 Okay.
Is the quiz very long?
It's 3 questions, but
Yeah. But I think the last one for sure, at least, is going to be a super long one.
The wrong one. My home teaching family called me and they need a blessing, so I need to take off at 7.
Oh, okay. Well, if we keep up the pace, we should be pretty good.
yeah.
Okay.
Checking your answers to the preparation assignment. If there's any, take the time to discuss the process of finding the solution.
So I did have a question, but I guess it kind of goes along with number 2 because it says to discuss the SSA PowerPoint. I don't know if everyone had a chance to go through it.
I did.
I just had a question. I don't know if y'all have it specifically. I'm talking about slide 18, but if you don't, I was just wondering how they got how there's the little triangle and a big triangle. Let me just draw it out. So I don't have to like dig through a million slides.
You said slide 18?
Yeah, I think it was slide 18.
Mm-hmm.
Yeah. So on slide 18, it's got angle like alpha 1, and then it's got alpha 2. And it says that alpha 1, it was like in order to get alpha 2, I think it's saying in order to get this one, all you have to do is subtract this one from 180 to get like this angle. And I was just wondering why these two are considered equal, or like why are they considered, I don't know, significant to each other, if that makes any sense. Yeah, because you subtract alpha 1 or 180 degrees by the degrees of alpha 1, and it gives you. Oh, wait, hold on. Did I just. Oh, never mind. I see what's going on. Of course, when you ask the question to everybody else, you end up looking stupid because.
Could you explain?
Okay. It's solving for the first triangle. Yeah, it's not doing this one. It's solving for this last angle right here, and then you're just using these two to calculate 180. That's I thought it was using this one to get this one over here, but okay, never mind. Of course, I figure it.
What? Okay over there. He's like.
Okay.
Well, I guess anyone else have any other questions from the PowerPoint, because it does want us to review it.
Discuss it. I had one question, but I was in the math lab when I was looking over that, and so they were able to help me.
You like live in the math lab.
Basically, yeah, that's pretty accurate. I spend a lot of time there.
It's probably where I ought to be spending my time, but I'm usually at work.
Same here.
Right? Yeah, it's so hard to do things with work and school. Like, I don't know how people stay sane. I'm not sane.
Me neither.
I just put on a facade. Inside my head, I'm just like, well, I'm done. Okay.
Hey, Josh, did you scan that one sheet for everybody, or?
Oh, I completely forgot about that. Well, let me do that right now. Sorry.
That's okay. You just got me really excited for that paper.
And then I killed your hopes. Okay. Do you want me to like email it to you or like text it or?
Email it works for me.
I mean, whatever's simplest.
I guess emailing would probably be the best. Let me look up your emails.
Oh, if you want, I can just type up the emails in the little chat thing.
Oh yeah, that would be super helpful.
Yeah, here. I'll just go ahead and do that.
Okay, thanks. Okay.
My poor internet can barely keep up with what's going on.
Huh?
My internet's barely working.
Let's see. So labeling the triangle. Anyone have any problem, I guess, labeling it? I think it just talks about more of working through it, and I thought the PowerPoint was super helpful. So I mean,
Yeah,
it was
definitely.
really thorough.
I'll need to take a look at it. Where is it at?
It's in the second part of the, I forget what it's called. Like there's 1, 2, 3 parts to the week. It's in the second resources, I believe.
Okay.
Yeah, it's in lesson 4 resources. And it's called the SSA PowerPoint. And it kind of takes you through the law of signs really well with figuring out angles and stuff.
Okay.
Yeah, I need to look at that.
Okay.
Oh no. Okay. One more second.
Okay, yeah. As soon as you're done, if you guys want to work on some of the extension problems, just practice and see how you feel about it.
What are we doing right now?
I'm on the instructions for the second Google Hangouts. And so like we went through the discussion, and if anyone had any questions about the PowerPoint, I guess just kind of what it does. But I figured we could just jump to the extension problems if we wanted to try and work through a couple of them ourselves, make sure we're all on the same page.
Yeah, we could do that.
Okay.
Okay, I think that's sent.
Thanks, Josh.
Did that work?
Yep, I got it.
Okay, sweet.
Yep. Thank you so much.
Oh.
Oh, yeah, that's all.
Okay. Okay, so we're going over extension problems right now.
What do y'all want to do? Number 1, the first little box with like 39.6 degrees, 18.4, and 3.7.
I like started doing that one, and then like something weird happened, and like I don't know what's going on. Because I set it up like all of the other problems, and I was pretty confident in it. But then when I tried to take the what's it called? The inverse scene or whatever to the output to here, let me just show you. So I started doing it, and once I got to here, I multiplied all of this together and got like a number with some decimals or whatever. And then I tried to take the inverse sign of that output so that this was left on its own. And my calculator told me that it was like undefined or something.
Oh, was it like one of those domain error things?
Yeah.
The key says there is no triangle, so it's a no solution.
That makes a lot of sense. I don't know why I didn't think of checking the key.
I know, I forget that that's there.
Yeah, sometimes I do too. Okay, that makes a lot more sense to me now. Sweet.
Well, there you go.
Got it right, and you didn't even know it.
Right.
Okay, so do we want to try that second one then?
Okay, let's try the second one, and if we're feeling confident, then maybe we can move on so it's not too late.
Yeah, definitely. Is 52.5.
Okay.
Working on it. The internet's just doing this, so it's like. Should start printing. Oh, okay. And then I can just use that. See. That's a lot of English.
Okay, I think I got some answers.
Okay. Give me 1 sec.
Okay.
Okay. I'm good.
So for angle alpha, I got 21.8.
Yep. Is it rounding to just the 10th for when it's a degree?
I
That's what it usually goes to,
Okay.
unless they ask for like round to the nearest hundredth or thousandth.
yeah.
Okay. Awesome. So then that would make the other one 129.6.
Mm-hmm.
Yep.
Duh.
And then for side C, what did you get?
Let's see.
Uh,
That
yeah.
4.36. Oh, I can't be right. I don't think I put this one in right.
For the second one, the side.
Yeah.
So I got 84.5 on it.
That's what I got.
I don't know. Oh, there we go. Sometimes I'm bad and I shortcut the answer. I'll save a data in the answer thing and plug it in, but my answer was I saved an old one, so that's why it's not coming up right.
Oh.
Here we go.
All right, we're all there. Do you have any questions?
No.
I think those were pretty good.
Yeah.
Feel pretty confident about. I don't know. I like this week's lessons. I feel better about it. Okay. Well, let's start tackling that group quiz so we can get done.
Yeah, definitely. Okay.
Who wants to submit it? I don't know if anyone in particular, or I feel bad having the same people all the time do stuff.
I could probably have the worst handwriting out of everybody.
I mean, I can go ahead and do it for this week if y'all want, so it's just not the same person. I forget who keeps doing it.
Sure.
Unless you want to do it, because sometimes I don't write things out terribly well.
I'm fine with whatever.
Yeah, so we can always like do that this week, and then we can start like rotating through us. That way, we all just take a turn.
Yeah.
Okay.
Do it like alphabetically by our first names, or I don't know, whatever would work, I guess.
That sounds good. We've only got a few more weeks, right?
Yeah, several.
More or less.
Okay.
Okay. So number 1, explain why the expected response for arc sine of -1/2 equals -pi/6 and not 11 pi/6.
Arc sine 1/2. Explain why the expected response.
So I know that arc sine is the inverse of sine, which I guess would give it the value. I don't understand why it's negative. Yeah, if it's a -1/2, why it wouldn't be like 11 pi/6. So I guess I'm trying to work that in my head.
I've actually had this question, because I've noticed on some of the, I think it was the homework problems, but like sometimes instead of having you put the positive radiant or whatever, it'll have you do the negative one. But they're like technically the same thing if you think about it, but like why does it prefer the negative one? Is it because it's like easier to like think about and because think of it's like it's that first notch on the unit circle.
Well, something you were saying is like, yeah, it's the first one you get to, and I don't know if this is necessarily it, but in the textbook it says that the arc sine is the arc length of -pi/2 to pi/2. So it's only in that given section. So I wonder if that's the reason why it wouldn't be 11 pi/6. We would have to find the value in just that, the closest bit in that little section. If that makes any kind of sense.
Making sense is really all relative when it comes to math.
Right? Because on the unit circle, it's positive. I don't know.
Yeah, I don't know. I mean,
Is
the
it
only
just
way that it makes
your
go ahead.
Well, I think you were saying earlier, just since it's a faster way to go around it instead of the 11 pi/6 with the 1/2. It's like when you have a negative radians and it goes the opposite direction anyway, it goes clockwise. Wouldn't that be the same thing for an inverse?
Oh, like normally you'd go to 11 pi/6, but since it's the inverse, it goes up instead of going.
Split the entire unit circle and then put the negative there.
So because it's an inverse, we go backward. Okay, that makes sense.
That makes sense?
Yeah, that would make sense.
Okay.
Okay, yeah, that's easy because arc sine is inverse.
Because if I said -pi/6, then you'd know pi/6 the other direction, or sine of -pi/6, then you'd say -1/2.
Arc sine is inverse, it goes backward. And the -1/2 value. Let's see. Trying to find out the best way to word this. That sounds good. So arc sine is the inverse of sine, which, like, I understand it in my head, the inverse of sine. So it would go, is backwards a proper term? Circle?
Clockwise
to
instead
pi.
of...
Oh. That's a better way to do it.
Clockwise?
Yeah, so normally it goes counterclockwise, but when it's negative, it goes clockwise.
Okay. So it'll go clockwise since it is negative. Or since it is the value of negative 1/2. Okay, and that puts it at pi over 6.
Yeah. Or
So
negative pi over 6.
Negative pi over 6.
Oh, okay.
Yeah.
Which is negative. This gives negative pi over 6 since the arc sign is negative. It's arc sine of -1/2. Like rewording it like 100 times. Okay. Got that one written down.
Okay. If the sun is far enough away that an object and its shadow will make a triangle, that is a similar triangle with another object and its shadow. In geometry, we learn that if two shapes are similar, one is an enlargement of the other. This means that the two shapes will have the same angles and their sides will be the same proportion. What information would be needed to calculate the height of the Ricks building, feet and inches, without actually measuring the building? After you list the information needed, set up the problem as if you were going to solve it. Draw and label a picture and set up a ratio.
Well, the easiest way to figure that out would just be at the blueprints of the building.
Right?
But I guess we can't pick that option.
We're all little.
Ask somebody in the apartment.
It didn't say we couldn't.
Yeah. Set up the problem as how you'd solve it. That's what I do.
Well, let's see.
Well, if the
it'd be pretty much set up the way number 3 says it's set up, more or less.
Yeah.
You would just need to know like the angle of elevation from a point on the ground.
So what is it?
Picked down like picked out something that you could measure, like a 5-foot post or something. And then you measured the distance from the post to the end of the shadow.
So like the sun, the building, should there be a post right here that's like shadowing on it? Or would this make an angle? Guess that's what I'm just trying to see is.
Let me see if I can figure it out real quick. So I think what we're saying is you have the building, and then you'd have like the shadow. You know, we're gonna get to see my art skills today.
Triangle that is similar with another object and its shadow.
So we have the building
That's
here.
cool.
And then we have the shadow coming down. So we have like the sun over here. Beautiful. And then we have like a 5-foot pole with its shadow. So we'd measure this part right here and find out the ratio between those two. And then we could figure out what the ratio would be to these over here so we could figure out the height of the building. If that makes any sense.
Yeah.
Okay.
It's a beautiful picture, I know.
Ratio this.
Well, that's how it looks to me. Like, if we have this angle of the shadow here with the 5-foot pole over here, we know this pole is 5 foot. So we can measure how long the shadow is for this one. And then we just get the ratio. So if this ends up being like 2.5 feet, wow, that's beautiful. So if the shadow is 2.5 feet, then the shadow is half the length of the pole. And so if this measured out like 75 feet, then the building would be 150 feet because the shadow is half the length of the building.
The hypotenuse of the shadow or the length of the shadow?
The length of the shadow down here, this part.
Okay.
So if this ended up being half, so we had the 5-foot pole and then this is 2.5, then this would be half of that, which would also mean that this would be half of the side of the building.
Oh, I see.
So,
Okay, and if we said 75 was the length of
the shadow
that
here.
shadow,
So that
then
would
that
mean
would give us
150 for the length of the building, or height of it.
size ratio here. Calculate the
Which
height.
building?
Okay.
I was just making up numbers.
Okay.
It doesn't necessarily have to be 150 foot.
Guess I'll make it a flagpole. How big's a flagpole? Like 20 feet? 2 feet? Sure. Okay, so I'll redraw it better, but the building, the length and the height that we're solving for, and flagpole, the length of the flagpole and the length of its shadow. And I can set up a ratio to, like, if this was 5 over 2.5 equals h over 75 as the ratio. Because draw and label a picture and set up a ratio. Yeah, so does that seem right? Like I said, I'll redraw it because I write everything again nicer. But the picture, I'll label all the parts, and then the ratio of 5-foot stick to shadow, height to shadow.
Yeah.
Yeah.
Cool. That's what I was getting at. Yep. So that's pretty much it for number 2. We just had to set it up. We don't actually have to solve it.
It's next test. Okay. So for number 3, angle of elevation of the top of the Angel Moroni and Rexburg Temple. Angle of elevation. Here. Did I draw a picture? Put X on the ground. 47.8. X on the ground. So is it saying that if this is part of my art, and this is point X, is this the 47.8?
No, the 47.8 is the angle right by X. So X is the point, and then 47.8 is the angle that, where your pen is.
Okay, of the X. Okay.
Yeah.
From point X. Oh, okay. Yes. This is why we're a group. So that's So the angle of elevation, is that the angle by Moroni?
Gotta go.
Oh, I get it. It's two different triangles.
Alrighty, where are we at?
Working on number 3.
Okay.
I've almost got it.
I messed up a part of it. I assumed the 75 was the length from the temple to Y, but no, it's the length from X to Y.
Yeah.
I messed that up in my head.
Okay, let me put this in my calculator. Tangent of 47.8 minus the tangent. Does it say how many fingers to round it to?
I would
No,
assume
I just
just
imagined.
tenths.
Just once?
Yeah.
Okay, so then it's asking for what is the height of Rexburg Temple?
This
Oh, man. Okay. So then tangent. Into 7.1 to the tangent of 6.5.
It would be 123.4 feet.
1 second. What did you say you got?
123.4
for the height?
feet. Yeah, for the height of the
I
temple.
got 168.6 feet.
For your triangles, because I don't doubt if I totally mess this up, but what'd you get for? I guess maybe we can work backwards and see what'd you get for the angles of this triangle and the lengths, and then we can kind of work backwards from there.
So for my ratings, here, let me kind of small. So right here, let me make that a little bit more clear. So for this angle, I got 132.2 because I did 180 minus this angle to get that angle.
Okay.
And then I did 180 minus this angle to get this angle.
Okay, did you get
I don't know
11.3
if
for
that
that
is
one?
actually. Yeah, one sec. Yeah, I got 11.3.
Okay. What did you get for the length of that middle? Nope, sorry, wrong one. This middle part right here. Oh, sorry. Of this one.
I got around 212.
Okay.
I didn't
I got
solve for
two.
that middle part.
Wait, so what was your guys' final answer for the height? What did you both get? Or what did everyone get?
I got 168.6.
Okay. I got 157.4.
We all got different answers.
Yeah, I got 123.4. We're all over the place, man.
Just add them together and take the average.
Right.
It's about this high.
Wait, so what was the process you guys did then? So Josh was saying, what did you do?
So
So you found.
Sorry.
I can't read that really. Let me make this screen bigger. There we go.
Oh, fancy with tangent, man.
Oh, tangent. Oh, I don't know. I used what? Yeah, I don't know if I did it right then. I used sine.
Oh, I see the formula you did.
Mm-hmm.
Oh, okay. I'm seeing what you did there. Huh. Yeah, see, I did the sine of the 11.3 over 75, the length we knew, and then sine of 36.5 over this angle, and that got me the 200 something, but okay, let me see.
Yeah, I did something similar to what you did, except I used 70 feet over sine 11.3 equals c over sine 36.5 to give me that middle length, or the middle hypotenuse.
I'm just following. Or go ahead.
And then I was saying I just used that line to find the length or the height. It's just we had like an example in our homework that was like this, and I just used the formula that they used with the sine.
What I did. But my example was, or it gave it in tangents.
Oh. This was in lesson 3 of week 8.
Can that tangent one be used if it is a right angle triangle? I was under the impression that was for if it wasn't a right angle.
Tangents can be used.
Oh, okay. I just get confused.
Yeah. Well, we're in a fun conundrum.
Okay, so I just finished it and got 168.7.
168.7.
Awesome.
168.6.
168.6. Hey, that's y'all are in the ballpark. Great.
Just put 6 or 7.
Or 7.
Can we put like a range? It's like in between 155 to 160.
Something like that.
Around there, give or take. It'll settle over time, so it'll.
Oh man. What process did you use, Addison?
So at first I used the angle side angle to figure out how long the side of I could probably draw it better. Hang on.
Oh, Giovanni, those are my pens.
1 second.
Do you want to put them in the ball?
So I used the side angle side thing. So right here we know, or angle side, I mean, or no, side angle side. I used this angle and then 75 and then that angle. So I figured out the length of this side here for this shadow coming down.
And what?
And then I used angle side.
What length did you get for that middle one?
So I got 227.7 for that middle thing.
Yeah, see, that's what I got for the middle length was the 227.7.
And then I used angle side. So I got the 90 and then the, what was it, 47.8 here. And then I typed in the 227.7 and I got the, what did I say, 168.7.
Okay, hold on. You got 167, but hold on. Oops.
Yeah, I did the same process, but I got 212 for that middle section, so I must have done something wrong.
I think it really matters like what order you put in the angles at.
Yeah, so here's what I wrote. Let me see if I can find it. Here's how I set it up at first. Where is it? Like that. And then it led me to that. So I don't know. I'm retyping it into my calculator. Because you both got the same answer for that middle section.
I didn't solve for the middle section.
I figured that'd be the easiest way because that would give me the length of the side for that second triangle.
Yeah,
we already had the two angles.
Yeah, I just worked it again. I got the 168.7 for the height. Or well, 168.6 technically is it, but I just rounded up to 168.7.
Yeah, my full answer was like 168.681, so I just went up.
Yeah, see that's what I got working through there. So it's got to be around 168, right?
We'll just say 168.5, or that doesn't work. Yeah, 168 and 6.5, 168.
Can we just say 169 and put the little squiggles?
Yeah, just put roughly.
Yeah, the squiggles, like roughly 168 point, I don't know.
I put 7 just because we've gotten multiple times where it.
Yeah.
Yeah, okay. It looks good to me.
I think the biggest thing with it is just the rounding.
Yeah.
Because I rounded for that side too that ended up as 227.7. So I rounded for that too, which probably alters the height a little bit.
Oh, you're right. I bet. I wonder if not having rounded would have made it a difference. I can work through it again. Let me see if I can plug it in again and see if that gives us any different thing.
I mean, as long as it's like more or less around 227.7, like it's going to be about that height. It just might be a little different depending on which way you rounded the 227.7.
Yeah, and I think with, with showing the work, I think she'll see that obviously, the thought process and stuff was there. Yeah, see, if you work it at, well, never mind. If you work it out with without rounding that 227, it comes out to 168.66, which I guess would still round up.
Yeah. 6.7. Yeah. All right.
Sounds good to me.
All right. Well, I will clean up this. I always like to rewrite it because I don't like my first draft of it. But I've got those all worked out, and I'll get them submitted today.
All right. Thank you.
Sounds good.
Thank you, guys. Y'all have a good one.
See y'all
too.
next week.
See ya.